Okay, what is the probability that four randomly selected people all have different birthdays? Okay, we'll ignore leap years, so that we'll say 365 days in a year. And we'll round our answer to four decimal places. So this is we can think about this as a four-step process. Person number one, what is your birthday? Person number two, what is your birthday? Person number three, and then person number four. Okay, so we have basically, let's look at it like this. Four people. This is person number one, person number two, person number three, and person number four. So let's think about how many, for this criteria to be met, the four birthdays are different. How many options are there for each person's birthday? Well, person number one could have any birthday. So there are 365 options out of the 365 days in the year. But for person two to have a different birthday than person one, whatever person one's birthday was, let's say it's January 1st, well, that's no longer an option. So person number two has now only 364 options out of the total 365 days in the year. Now, for all people to have different birthdays, person number three cannot have the same birthday as person number one or person number two. Let's say, for example, person number one was born on January 1st, and person number two was born on January 2nd. Well, then those 2 days are no longer options for person number three, and so there are 363 possible birthdays for person number three out of the 365 days in the year. So we want all have different birthdays. Okay, let's say person number three, nothing too creative. Let's say person number three was born on January 3rd. So now for all four people to have different birthdays, person number four cannot be born on the 1st, the 2nd, or the 3rd of January. So those three options are gone, leaving 362 possible birthdays out of the 365 days in the year. And for this sequence of four events to happen, when we're looking at the probability, we're using the multiplication rule. Okay, so let's come over here to the calculator. 365 over 365 is 1, so we don't need to say 1 times. So just start with the 364 over 365. That's the probability that person 2 doesn't share a birthday with person 1 times the 363 over 365. That's the probability that person 3 doesn't share a birthday with persons 1 or 2. And finally multiply that by 362 over 365. That's the probability that person 4, who let's say was born on, I don't know, let's go with January 4th. That's the probability that person 4 doesn't share a birthday with persons 1, 2, or 3. Okay, so our probability is, well, we should probably use squiggly equal sign, so it's about 0.98364, and so on. The directions say round to 4 decimal places, 1, 2, 3, 4. Okay, so we're going to round here. The next digit after the 4th decimal place is a 4, so we don't have to round up. So let's say our final answer should be a probability of 0.9836, or just over 98%.